and B, this will fit really nicely with the lecture that's the video lecture that's assigned for Friday for a case discussion. You might choose, if you want to sort of look at these two lectures together, and kind of try to dovetail the teachings of that VC with sort of the mechanics of going to market or picking a market for the invention. You'll notice that I have both the Cox logo and the Lyle School logo on here. Part of my job is going back and forth between the two schools, and this set of slides, of course, came from the work in engineering entrepreneurship, and also an institute for technology innovation and entrepreneurship that I'm fortunate to run. So the toolkit that I wanted to bring up today was something called the Business Model Canvas. And it's a really simple tool, but it's also a really good tool, because if you're thinking about taking an invention or taking a product to market, and I always think about this in the context of technology products, but it really works for any product. This chart, or this set of things to sort of think through, become pretty comprehensive for a small business. And I'm going to walk you through some of this stuff, and then we'll do some examples on how you might use this. But here's and I think I sent out a picture of one of these versions in an email the other day, and of course I'll send out these slides, and you have the recording for this video as well. But basically, the way I look at this chart, or this set of activities that is running a company, falls into two sides of this. The left-hand side, or this side of the canvas, is all the back office stuff, all the things you need to do to run the business. You know, who's your partners? Where are you getting your supplies for the product from? What are your key activities, manufacturing, sales, and so on? What are the key resources that you need? A lab, a factory, a relationship perhaps with a fab, a foundry, like we studied last week. And then all this stuff here builds up to how much does it cost you to build your product and go to market? What's your cost structure of your company? The other side of this business model canvas is all the customer facing. This is the stuff that this is where the revenues, the money that people pay you to get your product. Who is your customer? How do you relate to your customer? Is it online? Is it through handshakes? Well, that's hard these days. But you know, is it through a supermarket or a drugstore? You know, how do you interchange? How do you interact with them through your channels? And how well do you know them? Are here. And then the centerpiece of all of this is what they call a value proposition. And if I was one-on-one in my office, talking to somebody about a value proposition, one of the things that I've done in the past is I've asked, so, you know, whoever I'm talking to, if they have a $20 bill in their wallet, and I say, give it to me, and they stop. And they start asking, why should I give you my $20 bill? And that is, to me, the essence of this box here, the value proposition, because it is very much the question, why should somebody give you a $20 bill? And it probably means that you're giving them $40 of value, the things that they value up to $40, and then they're pretty happy giving you $20 for something that they think is worth 40. And if you can make that for 10, your cost structure, then everybody's happy. The business goes forward, and and life is sustainable. So here's a question. Here's a project that I was involved in a few years ago. It was an invention, and the product had to do with medical imaging and an add-on for medical imaging. And I won't go too much into this other than in order to scope out the market, in order to see how big the market is, if you're going to restrict yourself exactly to MRIs, the first question to know is how many MRIs are there in the United States? And if you know how many there are in the United States, then you might be able to multiply by 2 or 3 or 4 to get the global picture. But you know, if you're starting a company in the United States, then maybe the United States is the first market to think about. Maybe not the best, but the first market to think about. And you know, in this case, you have to answer the question: how many MRIs are there in the United States? Now, of course, you're going to Google this, but I wanted to sort of share with you a thought process that was developed, you know, A, pre-Google, and B, allowing you to think a little bit better, a little bit more substantively about your market, about the size of the market and what it is. And so where are MRIs found? Well, MRIs are generally speaking found in hospitals. Maybe there's a few more in imaging centers, but those are fairly linked to hospitals as well. And so the first question is, how many hospitals are there in the US? And then that's a hard thing to answer, but maybe we've spent time in a particular part of the United States. And for this example, I'm going to use Dallas. So how many hospitals are there in Dallas? And if you kind of go through neighborhood by neighborhood and kind of think things out, you've got about, you know, a couple dozen hospitals there. And, you know, does every hospital have an MRI? Does it have more than one? And, you know, if you walk through some of these hospitals and kind of, you know, go down to their imaging center or do a little bit of other exploration, you sort of start to visualize, start to think about how many of these facilities and what these facilities look like. And so they're usually 2 or 3 MRI machines per hospital. And then you can say, okay, well, so what do we have here? Well, we've got 330 million people divided by 1.3 million people in Dallas. That's about 250. So there are 250 Dallases in the US. And so you can quickly scale up, you know, but number of MRIs, number of hospitals, population, and then the overall estimate. And a low estimate is 10,000. A high estimate is 24,000 MRIs in the United States. How did we do? Well, if we do a web search, and ask Google, we get a number that's about 11,500, and so sort of at the low end of this estimate, but well within this range. And one of the things to kind of just pause and think about here for a second is, you know, does it really matter that there are 11,500? Is that the same? Is that about the same information as 10,000 or 15,000? And for this kind of a picture, it absolutely is. For this kind of a picture, it really does allow us to frame the market. So in engineering, and certainly the calculations that you do for homework and exams, there's a lot of precision involved in those, a lot of design precision. But it's really sometimes beneficial to just keep in mind an order of magnitude, a coarse perspective on things, and that's what this train of thinking A allows you to do, gets an order of magnitude, and B, it allows you to sort of, as you work through it, it allows you to start to visualize what some of the aspects are of this marketplace. You know where you're going to have to go. You're going to have to eventually go into hospitals to make your sale and to establish your relationships with customers. So this kind of thinking, I think, spurs imagination, and that's something that's very, very useful for this. Now, it's also useful to kind of segment out the market a little bit more. The particular product that and I'll talk about it in the next slide, but the particular product is more suitable to the high end MRIs, these 3 Teslas. Tesla is a measure of field strength, and 3 Teslas is a pretty substantial field, magnetic field. And you can see from the picture the effects of a 3 Tesla magnet. If you have a piece of metal, like a chair that's sitting across the room, this thing will pick up and suck this chair right into its core. And so it's a really, really, really powerful field. A 1 Tesla magnet is really, really powerful. And we're talking about 3 Teslas down here in this high end, roughly 20% of the market area. This also sort of tells you some of the aspects of MRIs. They're very dangerous to work with. Any kind of metal implant that's magnetic will want to leave your body and go to the magnet. So a belt buckle, for example, will pull you towards the magnet. So there's a lot of care, and this is a hazardous environment to be selling into. And so people are nervous, and they follow procedures and policies. And so again, that talks to the flavor of the market. It forms an image in your mind as a business person going to market. It's also interesting to note that the size of the number of Teslas corresponds to the price of an MRI. The price of an MRI is about $1 million per Tesla. Okay, so here's the product that we're talking about, and what it was actually for something called a functional MRI, which allows you to look at brain activity. And the people pay $3 million plus for these 3T MRIs, and they want a 1 millimeter little cube, a little voxel, a little cube of information with a resolution of about 1 millimeter. And because of motion, because of movement of the patient, you blur this out to about 3 to 5 millimeters. So very much bigger than what the resolution that you want to have. And you could do some image processing, but you can't get back to the absolute lowest 1 millimeter theoretical. So what we developed was, and the problem was brought to me by the head of radiology at UT Southwestern Medical Center, and we started to solve the problem together over a lunch, and that led to a series of patents and research grants to support the development of this product. And what we were doing was we would have a fast camera with some filtering, signal processing. Remember, we've been talking a lot about that. And we processed the images very quickly at the camera so that we could measure the movement, and then we could feed that signal back into the magnet in a prospective manner so that the magnetic field and the electric fields of this ride along with the motion. And so in the frame of reference of the data, the fields were just following along. And so that was very useful. It made a lot of sense. However, it demanded some cooperation with the MRIs, with the MRI companies. So again, if you think in terms of relationships, you had a small startup company talking to big magnet people, and did you have what was your market power, if you want to think of it that way? And there were some developments. We talked a little bit about standards, and so there were some DICOM standards for the images, and that was hugely useful because an open standard for the images meant that we could do our image processing very, very quickly. And then eventually but for reasons that we hoped but couldn't count on, there were some standards that allowed an opening up of the machine to companies that would be making these prospective head tracking solutions. But when we started it, there was by no means obvious that would happen. So again, sort of a risk, sort of a looking ahead, trying to figure out what are the barriers and what you could do. So my graduate student was thinking about starting a company. Eventually, he did start a company. He called it MRRA, and I think it was medical research something or another, magnetic resonance research associates or something like that. And if his company was just about fMRIs, what would that company look like? You know, what would it? How big would it be? What would it? How opulent or how nice would the office be? And so if you think about about 2,000 3T systems, maybe a quarter of those are directly applicable to the product. 500 MRIs, maybe globally you've got about 3 times that. Maybe you should say that all of the total available market, TAM, should be all the high field strength MRIs, like 2,000 units. And then to get a dollar value for the market, we need to start thinking about pricing the product. And so what we did was we thought about this, and we said, okay, we should never price our product by what it costs us to make, right? It doesn't address the value of the customer, right? It's that $20 bill exercise that I went through. If I can't deliver that value proposition to the customer, then the customer doesn't care what my costs are. You know, they only cares about what it costs them. It's trite, it's formulaic, it doesn't really help. It ignores strategies, and ignores your competitors' costs. And so our cost for this was $10,000 without any redesign for cost. And if we did want to invest engineering effort, and that's a risk, we could potentially design it down to about a tenth or a third of that. And there's a little quote here that I like from a guy that I really, really like, Davido. When prices are set too high, products never fully develop their markets, leaving pockets of opportunity for competition. When prices are set too low, the company gives away profits needed to finance the future. And Davido, going back to last week's lectures, Davido was the genius behind the little sticker Intel inside that turned the market power from the people that sold you a computer to the people that provided the chips one or two layers back from that computer. So how much would you spend to get the most out of your magnet? What is it worth to a medical community, an imaging community, to get that 1 millimeter of resolution instead of a 2 millimeter or 3 millimeter resolution? And so again, if you sort of think about the total system cost and shoot for a reasonable percentage, you've got about $3 million for the 3T magnets. 1 to 10% of that is 30 to 300K. That sort of gives you that range of what a reasonable price should be for that. And so if you go at 1% of the total system cost, your gross margins, and that's revenues minus costs, are 70%. So if you're selling something so we pocket 20K for every 30K sale that we make. That goes directly back into the operations and the profit of the company. Hugely great margin, absolutely out of the staggering margin. And then we can take a look at the total available market at that price, 10% per year. that suggests a 12-person company, you know, and with 12 people, you can have somebody in operations, you can have a few designers and engineers developing your future generation products. You can have, and very, very importantly, you can have sales and technician support for when things don't quite go right. So a 12-person company is a very nice sized engineering company. You'll never get hugely rich. You'll never, but you'll make a nice, it's a nice business. It's a very sustainable, very nice business. The other thing about this from a market perspective is the magnet people, the people that make the machines, they couldn't care less. They'll never enter this market because it's completely noise to them. It completely defocuses them, and that's why they started to come up. That's why they started to come up with an interface standard that made it really easy to plug back into the magnet. They saw several companies emerging in this space, and they didn't want to bet on any one technology. And they didn't want the headaches of trying to convince people what was wrong with their magnet, you know. So they just let this part of the market open for people like this MRRA company. And then it also matters to some extent, and this goes into your channel, it goes into your value proposition. You know, it kind of values how you actually collect your money. And so far we've been sort of thinking of this as a one-time hardware cost, but that doesn't match with how the customer gets that money, because the hours of the magnet are billed out by $500 per scan or $500 per half hour. And so if this money is flowing in, then you can match your collection, your revenue take to that cash flow. And then, so if you can design or can redesign your product in such a way as to bill by procedure, you could really just dovetail real nicely with the cash or the money flow of the particular market. And so now you have, so what we did was we used a target to track the motion, and the target was a potential consumable. And so what that does is that completely de-risks the hospital, because they'll only pay us if they're using the product. If they use the product a huge amount, there's an upside for us. And if they don't use the product, then boy, we better figure out why we're not adding value to and why they're not using the product. And maybe we shouldn't be in business if we can't get them to use it every single procedure. So here, let's go back to this business model canvas. Let's sort of quickly go through what each one of these boxes might look like. We'll start with a value proposition, and that is get the most resolution out of your MRI. Better diagnostics, better suited to patients. Okay, and so this was the value proposition. We were looking at the customer segment of hospitals. There might be others. It would be a difficult sale to a customer because we had to talk to the doctors, we had to talk to the nurses, we had to talk to the technicians. We might have had to talk to the financial people, depending on exactly how we priced it and the particular arrangements of the hospital. So again, it's one of these design wins. It would be a design win kind of a sale, which we've talked about in the past. We'd probably have to have direct sales force to go into the hospitals, and they'd probably have to have some application engineers. So now we're starting to think in terms of, if we have 12 people in the company and we have to be out there, this might be half of our company is sales force and application engineers. And certainly I've put these guys again as the key resources, those relationships that we would have with each and every one of our customers through these sales channels would be an absolute key resource. Key activities would be engineering and establishing relationships with the users. And then key partners might be the MRI manufacturers, except if they have a standard, maybe we don't care about them. Certainly the medical imaging community. And then maybe we don't build the product, maybe we have a contract manufacturer that builds the product. And so now we have our cost structure, which is how much it costs us to do this, manufacturing support, next generation engineering, looking at 12 to 24 million. We have instrument plus consumables, looking at revenues of about 6 to 12 million. And so things balance pretty nicely. You've got about $500,000 of revenue for every person that you have on your company. And that's an extremely profitable and also fairly typical high-tech company. And so that all squares away from a benchmarking perspective. So the question to ask is, what business are you in? Is there a bigger play that we could do? Is there a higher risk, higher reward option here? And so now if you start thinking about medical imaging at large, diagnostic imaging centers, and don't just restrict yourself to fMRIs, don't just restrict yourself to MRIs. Look at all of the medical imaging, and there you have 50,000 imaging machines. So a market that is that's 25 times bigger than what we had before, and they're clumped together in a nice focused 6,000 buildings around the U.S. And what's the value that we might offer? Well, we didn't go in and talk to the technicians. Actually, we did. But what we really keyed in on was the CFO, the Chief Financial Officer, and she told us that they lost 5% of revenues every year from motion artifacts. So what they would do is they would image a customer. They would send the customer home. Then they would realize that they didn't get the data that they wanted, and they had to call back the customer, and they had to use up their waiting room time. They had to use up their back office, and they had to use their machine time again. And so it really just bugged them that they had a 95% yield and not a 99% yield on using their expensive capital equipment. So could we build a motion alarm system that tells the operator to immediately rescan the patient? So this is a much simpler product, a much bigger market. And what would that look like? And here's the value of the 5% lost revenues. Prices per procedure were 100 to 500. Number of procedures per hour, hours per year, revenues per year, and this is per machine. 5% per machine revenues of $150,000 is the number that bothered per every one of her machines. The CFO was losing, in her mind, and quite rightly, $150,000 to $200,000 every year. So what if we priced it at something like $15,000? Then their payback, the machine would pay for itself in a month, and all of a sudden our total available market went up to $750 million. And so that's looking not like a 12-person company, but like a 100+ person company. So much more exciting, much higher risk, much higher reward, much nicer office building, if you think of it that way. The difference in the lobby between this company and the original one we spec'd out, night and day, right? One would have somebody to greet you in the lobby. There would be nice plants and furniture, and the first one might have a desk and a phone on the desk so that you could if you came in, you could call somebody behind a locked door and they could come out and. But here's our new business model canvas. The value proposition is more revenues from the installed machine base. The key relationship was through the CFOs and the center owners of the imaging centers. The channels would be in the beginnings direct sales, but probably also once there were repeat orders, once the word of mouth got out, we'd probably be able to automate a fair number of these orders and go through some sort of web interface for that. The key activities would be Salesforce, engineering, logistics, because we'd be shipping a lot of product. We'd be making sure that people like to use it. The technicians were actually the technicians at the imaging center were actually an interesting part of this picture. When you talk to them, they didn't see a problem. They didn't know the number of the 5 out of 100 mistakes that they make. And if you start picking on a technician and saying 5 out of 100 times you're wrong, boy, that doesn't go over very well, does it? I mean, that's not really a way to establish a nice relationship. So you had to tread very lightly, we felt, on helping these technicians, but not identifying them as the problem, right? So that was a very tricky kind of a thing to handle. We wanted satisfied customers. We wanted the medical imaging community to really embrace us, and in this kind of a battle, we wanted market dominance. Our goal would be 60% of installations every time if they had a motion warning system. We wanted a 60% market share, and so that would be the key activity for this company. Here's the revenue streams, and here's the cost of goods sold, looking at about 100 people to scale your company. All right, so what did MRRA end up doing? What did my graduate student who licensed the patents and started down this path, what did he end up doing? So now we have a very much a lifestyle kind of a business. We have a personal choice. Did this person want to manage a company with 6 to 12 people? Did this person want to maybe be a member of the leadership team, but not at the top of a 100-person company? And it turns out that this guy he had an interesting personality. He did fabulous design. He was an absolutely great engineer, and he had he was not as smooth on his people skills. In fact, he had some serious problems with working with people. And so he also was very much attracted to new technologies and didn't want to do the same thing over and over again. So what he ended up doing was finding new technologies. The first one he found was a different type of neuronal imaging called functional near-infrared spectroscopy. And he developed this beautiful system that won a Design Excellence Award to measure your brain activity using light that would come out of these fibers and go through your skull and look at the blood flow in your skull. And if the blood is oxygenated versus deoxygenated, that tells you whether those neurons right underneath that blood vessel was being fired. It's actually a beautiful thing. A neuron works pretty much like all other cells. They run an ATP cycle and they want oxygen. And so if you think about your brain, your head, and this is absolutely gorgeous. I'm sure you've all seen a picture of a brain, and you've all seen the sulci, the curves of the brain. And so you have this, we all have this impression that your brain, with all these sulci, all these curves, all these indentations and folds and valleys and hills, are just sitting in your skull. But in fact, through all those valleys runs a blood supply. And the only place in your body that has rings, interconnected mesh rings of blood, of arteries, is in those sulci on your brain. So your brain absolutely needs a heck of a lot of oxygen to do its calculations, to do its run. So if you think about that, those are big reserves of potential energy. Those rings of arteries are exactly the capacitors that we've been talking about in our RC circuits. Now, when a neuron fires, and this is something that I've been told by a neurologist, but I take that person at his word. But when a neuron fires, it flexes, it flinches, it contracts, and that action, that movement, that action of movement, pulls on an artery, and it pulls out the oxygen out. It pulls the blood and pulls the oxygen out of that artery, and so it's like I don't know if you've seen in the old movies a shower where you pull on the chain and the water comes out, and then you don't pull on the chain and no water comes out. And so it's very much like that action. So if you can find the pockets of these arteries where there is no oxygen, deoxygenated hemoglobin, then you know that the neurons underneath there have really been working. So this allows this device. Here's the whole device. Completely radical change. It used to be a whole rack of instruments, and now you'll notice that what he did was he designed it into the shape of a water bottle, so people could actually carry this around, and you could get a handful of measurements, but all day long from this little thing. So what he does is he developed a small lifestyle business. He designs instruments and he works with academic researchers to make them successful. It's a very small enterprise. It's one person. The lobby for his company is actually the foyer of his house. He works at home in his house. He liked that even before the shutdown. And so he chose on a personal basis to run a lifestyle business. And here's the final business model canvas for this one. It's just lifestyle, better technology for your research, better funding, better results. So very much not a mass market, individual partnership with researchers. They work at university and medical research centers, not in the hospitals proper. The channel would be to help them write proposals and get subcontracts on those proposals. He's doing really well if he supports himself at about $500,000 to $1 million a year of sales of all revenues total, either by selling the instrument, selling support to the instrument, or having some labor support for develop new instruments on these subcontracts. Key partners are the research community. Key activity is the relationships with the users and keeping up with the engineering activities that are resources that are available worldwide for his particular niche. He has the opportunity to create a flexible workforce. If things go really well, he might hire a few people, or he might hire some contract engineers, folks that work out of their houses as well and bill at a premium but don't get as much work, maybe. And the cost structure is what it costs of whatever he sold, and time and people, and at that rate he can support one or two people pretty nicely, and that's where he is. So we have about 10 minutes left or so. I'm going to be quiet and ask for some questions from you guys. I went super fast, but I think the big picture is fairly easy to get. Zach.
Hi, so I remember earlier that you said that you should aim for 60% market share. Like what if you've only like 30% or 20%?
Yeah. Um, so so that's an interesting perspective. Okay, so let me answer the question a couple of different ways. If you strive for 5% of a really, really, really huge market, you're just going to go out of business. You'll just be crushed by a competitor unless you have something very, very, very unique, in which case you're not looking at a 5% of a big market. You're looking at 100% of a tiny subsection of that market. If you have over 50% of the market and you collect your revenues and you invest back into R&D at a particular rate, let's say 10%, you will always be putting more dollars into future products than your competitor that has less than 50% and also does 10% investment. So that means you can hire better people, you can pay them more, you can challenge them more, you can improve your product more. And so over time, you will win more and more and more of that market share. And so it's really important. It's really important to strive for something like a majority of the market. Wall Street rewards the number one market player with a premium on their stock price. 30% market share is kind of considered by everybody an also ran. But this market was this is a much more competitive market than the other two, and so market share really mattered in this particular market much more than others. All right, Lauren has a question. I'm curious if ignoring the cost of the product when determining a price is unique to engineering, because I've seen on Shark Tank a lot of companies aim for a 50% margin. Okay. So Samir has a good answer. That's the beginning of this. Lauren, let me frame that a little bit differently. You need high margins to survive. You need positive margins to survive. You need high margins to flourish and to sustain yourself over time on average. But margins come as an afterward. First, you establish the price based on the value that you bring to the customer, and then you calculate your margins. And then you go to your investor community and you say, I've got a value proposition. My customers are delighted at this price. And by the way, I can make this product for half of what I can charge. So that 50% comes after the calculation of the price. It doesn't come before the price. I hope that, Lauren, does that help? And I'm glad you're watching Shark Tank. That's one of my favorite pieces of entertainment.
In my opinion, Shark Tank is good, but like it's not the best when it comes to engineers, because there's that, I would say inferiority for the investors. So I would just say, like, it's not the best advantage out there showcasing.
Samir, I think you're absolutely right. Engineering companies don't benefit from the 50 to 100K investments that the sharks on Shark Tank are offering up. Engineering companies, need, a couple million to develop their even a decent prototype of their product. And those investors are not patient investors. They're not going to be waiting a year and a half for you to develop your superior engineering product. So you're absolutely right. The whole Shark Tank situation is a different class of products.
Well, service and retail mainly, because
Yeah.
as you can see, most of it just goes to service and retail. Unless there's something that's like, technologically a consumer product that can serve like between, I would say, a product that, with a price of between $5 to $50, I would say.
Yeah, no, or these wonderful bicycles that can be have all these wonderful paint jobs and different decorative structures that the customers can design themselves, and you just have the relationship with the bicycle manufacturing to deliver those things, little tricks like that, not so Samir, what I differentiate is I talk about engineering entrepreneurship as opposed to sort of mainstream entrepreneurship. So it's what we do as engineers is a little different, and that's exactly why I kind of want to draw your attentions to some of the differences of the industry that you're going to enjoy going into.
Yeah, I agree. I always find that in engineering, we have to be thorough. We have to think through, like, not just on the business side, but we have to think about how we can help the consumer itself. Because our focus is to change. We're at a moment that we're continuously trying to change something. So we have to keep doing that. And, this business canvas, this business model canvas, which I'm really impressed because normally you don't really see those kind of things. It literally lays out in the simplest ways what your focus should be, how you should focus, and where you should be, where your expectations are, where you can be showing it. So it could be used anywhere, and you can basically share your idea with anyone. So
thank you. You're absolutely right. This is when I first saw this a little bit more than a decade ago, out in on a trip out to Silicon Valley in a bookstore, I was blown away, impressed by just how accessible this is. I learned all this stuff in the hardest way, the most convoluted way, and this picture just it's what a nice map to kind of lay out. And so I do think that this is a great tool for you guys, whether you work at a small company or a big company. All right, so you're going to go watch a wonderful, very iconic, old school VC venture capitalist talk about the business of venture capital, and I think there's a nice relationship between this tool and also the tool we're going to talk about next Wednesday, and then his lecture. So I hope you enjoy that lecture. Jack is just an absolute gentleman, very, very famous in the old school engineering communities of Texas and also of Silicon Valley, and even around Boston. And I thought he gave a great talk when he was here a couple of years ago, and so we videotaped it, and I hope you enjoy it. Like I put in my email, we'll do what we did last Friday. So you and maybe a friend